All right, so now we're going to talk about permutation. So permutation is simply an ordering of n objects. Okay, so we call that a permutation of the object. So for example, maybe we have the letters A, B, and C. If I want the permutations of A, B, C, I just want to know what are all the possible different ways I can write it. So I can say ABC, ACB, BAC, BCA, CAB. These are the possibilities. So I have 6 permutations of these 3 letters. Okay, so 6. Now, we could actually use our fundamental counting principle to figure this out because we have 3 letters, right? Okay, so there's 3 options for the first letter, but we can't reuse letters. Okay, so permutation doesn't reuse them. We're going to use them one time. So let's say the first letter is A. Now, how many choices do we have for the second letter? Well, we only have 2. And then the last letter only has 1. And then we multiply this together to get 6. Okay, now this 3 times 2 times 1 is actually a special expression. It's actually called a factorial. So what that means is we could actually rewrite this 3 times 2 times 1 as 3 with an exclamation mark. Okay, that exclamation mark is called a factorial. It tells the person that's looking at it to write 3 times 2 times 1. So if I had 10 factorial, I'd do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on. So it's just a shorthand notation that mathematicians like to use because sometimes we don't want to write all that multiplication out. Like if we had like 50 factorial, you'd have to do 50 all the way to 1, multiplying it together. That's too much. So again, this is a factorial symbol, and this is something you will see on your ACT, so it's important, okay? Now, if you see down here, I've told you about everything I just told you is in this box here about the factorial. So it is simply the mathematical definition is that where n is a positive integer where it is a positive integer, it follows that n factorial is n times n minus 1, remember that's the one after it, times n minus 2 all the way down to 1, okay? Now, this is the number of permutations of n distinct objects. Okay, so I had 3 distinct letters, A, B, and C. Those 3 distinct letters had 6 permutations. So if I was using the first 5 letters of the alphabet, the 5 distinct permutations would be 5 times 4 times 3 times 2 times 1. Okay, so let's look at another example. So 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. And how many different ways can the bobsledding teams finish the competition, assuming there are no ties? So, thinking this through, 10 teams, right? So it doesn't really matter that it's 4 persons, that's just extra information. All that matters is there's 10 teams. So how many ways can they finish? Well, it's talking about all 10 teams. So what we're going to say is this is just going to be 10 factorial. So this means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, and so on, which you can take your calculator out and multiply that out. 3,628,800. So it's important that you know what it means. So this is the different ways they could finish the competition. Okay, so first place, second place, third, fourth, and so on. Now, it might be a little easier to use a calculator. So, bringing up my calculator here. Let me make this just a little smaller. All right, there you go. So we actually do have a factorial key on the calculator. So it's under alpha F2 in my case. So a number 9, you see that? Number 9 is the factorial. So I can press the number 9 or I can use my arrow button and go down to it. And so all I have to do is start by putting the number in. So I'm going to have 10, and then I'm going to do alpha F2, option 9 again. And notice it does 10 factorial. Hit enter, and there it is. There's my answer. Now, I believe you can also find this under the math button, but you're going to have to look for probably a little bit. It's going to be under, I think, probability. Yep, so probability, there's number option 4. So that is the factorial key. Okay, so it's under probability, which is very helpful. All right, and how many different ways can 3 of the bobsledding teams finish first, second, and third to win the gold, silver, and bronze medal? Now this time we're not working with all 10 teams. We're working with 3 specific places. So if we think about our counting principle, well, we're looking for the different ways for 3 specific teams. So there are 10 teams that could finish first, 9 that could finish second, because the first team's already first, and 8 that could finish third. So 10 times 9 times 8 is 720 ways. Okay, so that would be the number of ways that those teams could finish first, second, and third. Now, another way to do this is actually to use what's called a permutation. So basically a permutation might look something like this, 10p3. So what this means is there are 10 teams, 10 things, so this is 10, taken 3 at a time, okay? And then what this would look like, so that 10 times 9 times 8 would look like 10 factorial over 7 factorial. Okay, so where this comes from is actually it's going to be 10 factorial over 10 minus 3 factorial. So what happens is we actually are subtracting the number of items, and notice what happens when we do this. So we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On bottom we have 7 times 6 times 4 times 3 times 2 times 1. And notice when those factors cancel out, we end up with the same thing that our counting principle gave us. So this is a particularly nice formula because it saves us a little time, especially if we have a large number of items. Now, the counting principle will work, but sometimes permutations is a little bit easier. Okay, so the formula for permutations, again, is denoted as n things taken r at a time. Okay, so the number of permutations of r objects taken from a group of n distinct objects, and this is given as n factorial over n minus r factorial. Okay, so it's important that you know this formula. Okay, it'll be useful. So now, let's go to number 4. It says you're burning a demo CD for your band. Your band has 12 songs stored on your computer, however you want to put only 4 songs on the demo CD. And how many orders can you burn 4 of the 12 songs onto the CD? So let's use our new notation. So we're taking 12 songs, so permutations of 12 songs, taken 4 at a time. So we would have 12 factorial over 12 minus 4 factorial. So that's 12 factorial. Well, 12 minus 4 is going to be, what, 8 factorial? So what we can do here is, if we're doing this by hand, and I'll show you how to use it in the calculator in just a minute, 12 times 11 times 10 times 9 times 8, I'm going to write that as 8 factorial, because 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which allows me to cancel out with the denominator. So if you were to use your fundamental counting principle, you would have had 12 times 11 times 10 times 9. Look right there, 12 times 11 times 10 times 9. So if we multiply these things together, we would have 11,880 orders, I guess, we'll say ways. So there's 11,888 possible ways you can order those songs. Okay, so that's quite a few. So I told you just a minute ago there is a way to do this on the calculator though. Okay, so especially if you're like on the ACT and you're time crunched. So notice under my probability button again, so in case you've forgotten how I got there, there's 2 ways to do it. So let me clear out of here. So you can get this under alpha F2. So notice it's option 7. Okay, that's one way to do it. Or, clear, you can go to math, arrow over to probability, and notice again option 2. Okay, so NPR. So it's the permutations of n things taken r at a time, and then you just fill in, okay, 12 over, and then 4. And now we're going to check to see if we got the same answer, and we did. Okay, so that can be a very useful tool, your calculator on your ACT when you have that time test. All right, let's try number 5. So number 5A, we're going to do that one together because I want to see the math, okay? I don't want you to just use your calculator here. So remember, we're going to have 5 things taken 3 at a time. So we're going to do 5 minus 3. That's the permutation. So 5 times 4 times 3 times, well, I'm going to leave it as 2 factorial because the 5 minus 3 is 2 factorial, which again, shortcut, lets me cancel that out. Notice I can see my counting principle, 5 times 4 times 3, So 5 times 4 times 3, so that 20 times 3 is what, 60? So that would equal 60, I think. You might want to double check. So again, on the calculator, if you wanted to double check this, I'm going to use the F2 key this time. It's option 7. So let's see, we were taking 5 things, 3 at a time. Yep, we got 60. Okay, so I would like for you to try B. Pause the video when you're ready to turn it back on, and then check with a calculator. Okay? All right, so hopefully you got 3,991,680. Okay? All right, so one more kind of thing to look at is permutations with repetition. So everything we've looked at so far has not had any repeating. Okay, there's 12 songs. Each song is different. 10 different teams, everything is different. But what if they're the same? So for example, well, let me give you the formula first. I guess that would be more important, right? So if you have repetition, okay, the formula is n factorial over, okay, so if you have something repeated s1 times, you do the factorial of that s1 times the factorial of that s2 times, and so on, so times, all the way down to whatever many times it has. Okay, so that sounds really confusing, but it's really not that bad. Let me explain. So, for example, we have the number, find the number of distinguishable, that's an important word, distinguishable permutations of the letters in the word Tennessee. Okay, so Tennessee has repeated letters. That means the N's, if an N is first, you don't know which one it is. Okay, so we're looking at distinguishable permutations. Okay, so I guess one way to look at it is like if you had the letters, I'm going to just show you an example real quick, okay? So let's say you're looking at the letters for I, okay? So I'm going to make this other E red, so it's distinguishable. If you were trying to turn these around, okay, if we're looking for distinguishable, these are the same, okay? These are not two different options. So that means we have repeated letters that create they don't create this, they create the same choice. So we're looking for distinguishable choices. So when we're doing this, we start with, okay, well, how many letters are there? Let's see, Tennessee has 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So we're taking 9 letters, so that's 9 letters on top. Whoops. Okay, now that everything's gone crazy, let's try that again. So 9 things on top. So now we need to look and see which things repeat, okay? So the E repeats 1, 2, 3, 4 times. So our E is going to be 4 factorial. The N repeats 2 times, so 2 factorial. Okay, so there's the N right there. I'll do that as blue, as red, so you can see it. So 2 factorial. And then we have these S's repeating 2 times, so 2 factorial. You don't have to put 1 factorial because 1 factorial is just 1. So now we simply have to figure out what this equals. Okay, so we can do this by hand, we can do it with a calculator. It's kind of our choice. I'm going to show you how to do it by hand. This is how I would do it by hand. 9 times 8 times 7 times 6 times 5 times 4 factorial, so that those 4 factorials would cancel. That's the largest one. 2 times 1 times 2 times 1. So what we'd have here is 4 factorials canceling out. I would say, oh, 2 goes into 8 4 times. So actually 2 times 2 goes in twice. So I would actually do some canceling out so that I could have smaller numbers to work with if I was doing this by hand. But you can see, or you could use your calculator. Okay, but either way, let's see, we have 6 times 5, 7 times 2 times 9, which I believe should equal 3,780 permutations. Okay, so you might want to double check my math. In fact, actually, let's pull up our little handy dandy calculator and we'll check it on here. So we'll use our factorial key. So I'm going to do alpha F2, use a fraction. So we're going to do 9 factorial. So again, this is under math, over to probability, option 4. Down, we're going to do 4 factorial. All right, let's see if we get that. Yep, 3,780 permutations. Okay, so again, so this is when you actually have repeated things. Okay, you have, in a word, you have the same letters being used more than once. Okay, because if you have the letter E 4 times, you're not going to be able to tell which one is different. Okay, so distinguishable permutations, that right there is the key word, distinguishable. Okay, all right, that's the end of this video.